Okay.
I would put planar.
This is not on the homework. I'm sorry, guys. But the homework's really short. You notice the homework's been getting shorter over time.
Oh, I barely started
All right,
it
here we
right
go. We on? Okay, here we go. So y equals 5x plus 4 squared minus 1. So the first thing we need to do is we need to graph this. At this point, everybody in this class should be able to graph this function. If you can't, I hope to see you tomorrow at tutorial. So, there are 3 transformations that have happened. What are the 3? Let's get 3 hands for the 3 transformations. Miguel, Humberto, and for Jaylee. Say that right? Left 4. So I started here, right? This is the original in orange. So I went left 4. 1, 2, 3, 4. Okay. Humberto? Down by 1. Okay. I'm here. And now what happens, Jaylee? What's the last one? Everybody hates the multiplication outside. Is it vertical or horizontal? Let's start there. How'd you know that? You just guessed. So that's not necessarily what makes it vertical, Marvin.
It's outside the parentheses.
It's outside the parentheses. So this is vertical. And then it is a vertical. Are we expanding it or shrinking it?
Expanding.
Right, we're just pulling it up. So it's gonna. So here's our graph, something like this in purple. So when we look at the purple graph, we clearly have a problem. Right? This is clearly failing the horizontal line test, right? If I drew a horizontal line here, it'll cross twice. Let's see. I mean, I'm like stretching it out this way. So it gets thinner, yeah. Steeper, yes. So we need to say, well, clearly I cannot find the inverse on the entire domain. I need to restrict the domain. So right now, what is the domain of this function? Right now, what is the domain of this function, Jasmine? All real numbers. And the range, Humberto? 0 to infinity. That was of the original one in orange, but David, I've now transformed it.
So negative 1 to infinity.
Right, because this point, remember, is negative 5, negative 1. So negative 1 to infinity. All right, here is the very easy trick. This is a very, very easy trick. The range of the original becomes the domain of the inverse. The range of the original is the new domain of the inverse. And let's see if this pattern holds true or not. So let's find the inverse first before I tell you, but it is going to hold true. So let's find the inverse now. So we've got y equals 5x plus 4 squared minus 1. So Mitzi? Say it again. That's the coordinates of this point. Oh, negative 4, negative 4, negative 4, negative 4. So I'm going to switch x and y. So x equals 5y plus 4 squared minus 1. I'm going to add 1 on both sides. X plus 1 equals 5y plus 4 squared. Divide both sides by 5. Come over here. X plus 1 over 5 equals y plus 4 squared. Take the square root of both sides. So I've got the square root of x plus 1 over 5 equals y plus 4. And then minus 4 on both sides. Now notice, I did not put the plus or minus. That would have been the big problem. Putting the plus or minus would have been the problem. Because if I had put the plus or minus, I would have ended up with what we had here, where we had 1 going here, or sorry, what I had drawn here, which was this and this, which would have failed the vertical line test. So I basically said, I only want the inverse on the positive side of the graph. And why is it the positive side? Because it's to the right of the vertex. It is to the right of the vertex. Questions? So let's graph this to see what this looks like. So again, we should all be able to graph this too. Like this should not be a problem for graphing either. So here we go. So I'm going to start. Here's my parent function. And I see 1, 2, 3 transformations have happened. So I went left by 1. So start here. Go left by 1. I went down by 4. 1, 2, 3, 4. And then I divided by 5. This is a horizontal expansion, so I'm stretching it out vertically. Excuse me, horizontally. Something like this. So this is F inverse of X. And again, guys, it's a sketch. It does not need to be perfect. Somebody asked, please give us graph paper. You don't need graph paper. Just sketch it, guys. It does not need to be perfect. Just label 1 point. This is the point that matters. -1, -4. Done. Oh, and look at this. The vertex here was -4, -1. The vertex here is -1, -4. Why does that happen? Because they're inverses. We switch the x and y's. Let's look. The domain of this inverse is -1 to infinity. What is the range of the inverse? What is the range of the inverse? What's the range of the purple graph? What is the range? More than Humberto. Salma.
-4 infinity.
Right. And this is the last thing. This is the realization right here. Why is the range here not equal to the domain here? And this is basically the whole thing. This is the entire point. Alejandro.
We're only graphing one side of the graph.
This is it. We only graphed from here there. We didn't graph the whole function. We didn't graph the inverse of the whole function because that would not have been a function. So we just said, I only want to graph from -4 this way. So the domain of what we graphed, or of what we found the inverse of, was -4 to infinity. We did not find the inverse of the entire domain. We restricted the domain. We restricted the domain. That's the key here. We restricted the domain. Yes.
So are we always going to graph the positive one? Since it's like plus or minus, we're always going to graph.
You can pick. You can pick whichever one you want. I do the positive one because I find it easier to worry about positive numbers.
So we only choose, we never graph both.
You know, yeah, we only choose we never graph both. Because if we graph both, this would have come down here, and it would not have been a function. So we have to choose one. We have to choose one side. So, key takeaway, if I have a function that fails the horizontal line test, that means it does not have an inverse on the entire domain. So what do? I look, I restrict the domain, so from -4 to infinity, and then I find the inverse. And then literally all I do for domain and range is just swap. This is why it's so important to know the transformations. It makes the graphing like so easy. Mitzi. Can't hear you. Okay, so the brown one is square root of x. I went left by 1. I went down by 4. So left 1, down 4. And then I just divided by 5. This is a horizontal expansion, so I just stretched it out on the side. And I tried to illustrate that stretch. And it's a sketch. Who knows if I really got it? I probably didn't. It doesn't matter. It's a sketch. Label this point. This is the key point. And then when you annotate this, identify this is a horizontal expansion. That's all we need. Cool. You have 26 minutes. Have fun on the homework.